Good afternoon, everyone. Hopefully you're here to learn a little bit more about using Plasticard in your modelling. So, where to start? We should naturally start with what is Plasticard. This stuff here comes in sheets between A5 and up to A1 size in white, black, grey, usually white. Is Plasticard. It's high impact plastic, it's a thermoplastic, it glues using solvents, generally known as Plasticard in the UK or styrene over in the US. It's been in use since about the 1950s for plastic injection moulding kits, all the sort of Airfix kits you used to make when you were little. And since the 70s it started being used in railway modelling for scratch building, things such as coaches. Don Rowland was a leader in that area. So advantages of using it: it can be easily worked using basic tools, easily cut and joined and shaped, takes paint very well, comes in lots of different shapes and sizes and finishes. It's relatively cheap, widely available, and what you make with it is really limited by your imagination. So there are some disadvantages though. The product you use to join it together is a solvent, which is hazardous to health and can be quite smelly. Working it creates plastic dust, again hazardous to health, so use with caution. Compared to etched brass sections, the plastic ones may not be as fine and are not as strong and robust. And if you use too much solvent, it can overly melt the surface later on after you think you've finished and result in a bit of a mess. Other disadvantages, using it can be quite addictive once you get the hang of it. So what forms does it come in? The most basic form is a sheet like this. This is 40,000th of an inch, 1 millimetre thick. I generally use nothing thicker than 60 thousandths because that's 1.5 mm. Gets a lot tougher to cut, and to be honest, there's no benefit in using multiple layers of the 40 thou. It'll go down as thin as 5 thousandths of an inch, which is quite expensive and quite specialist, and will melt very, very easily if you use too much glue. As I said earlier, it also comes in a range of colours, generally black and white are the main ones, but I've also seen it in grey. You can get it in clear, but that seems to be a different material. Turning now to other types you can get it in. So we have three main, to my eyes anyway, three main manufacturers of plastic sections. You've got Evergreen, and we've got here a sort of square or oblong section in hundreds of different variations of dimensions. We have different shapes, so here we've got a H, but they do L's, I's, triangles and things. And we've got rods of different dimensions as well, circular, hollow, tubes. So that's those. Other manufacturers can include Plastruct. They tend to do a bigger selection than Evergreen, also do specialist mouldings such as staircase hand railings, W-shaped trusses, and a whole range of other things as well. And we've got the homegrown slaters as well. So those are your sheets and sections. Coming up to different textures. Ones that are most useful to the modeller are things like this, which is a nice brick finish here. We also get the stone flat Plasticard finish as well. Both of these are from Slaters. Moving into slightly different territory, we get injection moulded types of sheet. These are significantly thicker. They come in smaller sheets and available from Wills, now taken over by Pico. So we've got the one I use a lot of, which is the coarse stone. We've got the corrugated sheet, which is meant for 4mm, but seems to be about right size-wise for 7mm as well. Paving slabs, could be used as stonework, random stone, lapped timber, floorboards, cobbles, more cobbles. So huge variety of different finishes are available there. two I use most often in 7mm modelling are these two, the corrugated and the stonework. Right, so that's what is Plasticard. We'll go to tools next. So I said you only need basic tools to use Plasticard. It's quite a small list really. If you're starting out, straight edge ruler, sharp knife, a file, set square, pencil for marking up, solvent, generally MEK is the best one to start with, and preferably something to stop you knocking the bottle over as well. It does make quite a mess. And a old paintbrush to apply the solvent. You can also add a drill as well for drilling holes, but that, give or take, is all you really need to start with. Anything over and above this is just making your job easier. So the other sort of tools you can add, a razor saw. First off, very useful for obviously cutting, different variety, well, different types of teeth, numbers of teeth, filing the teeth, filing the cut. The other reason I like using a razor saw is, and there'll be a theme here in my talk, abuse of tools. Not just cutting, but if you drag the blade sideways, you can quite quickly get a rough finish, which is a very good starting point to get a wood texture. So that's your razor saw. We've got a steel hard-tipped scribe punch type thing. You can use it to mark out. I also use it if I want to do a rivet head or something like that, just pushing the back a few times of the plastic, and out the other side you get a nice row of rivets. The other use of it is very good as well. If you're you want some more texture, if you're making stonework, you can actually use it to further develop the texture in there. Also good for continuing mortar courses where you've got an opening in a window, taking it round the corner with a deep scratch in the surface. So that's your scribe. Track cutting shears. Very good for just trimming down a little bit off the edge, and we'll use those later for something else as well, but cutting bits off sprues perhaps as well. Excellent. We also have a range of other tools such as a scribe, a sort of carving type affair for putting texture in, particularly if you're building up your own stone. One of the most versatile and useful tools, which is never far away from me, is the Tamiya Scriber. There are alternatives, but I think this is by far the best. Unlike a blade, which when you press down and pull back, it effectively pushes into the plastic and moves the plastic out the way and leaves a raised edge either side. This, when you pull it backwards, actually removes a layer of Plasticard in there, so you're left with a groove. Obviously very useful for making grooves, but again, if you want to add texture to something, that's another use for it in there as well. But yeah, very useful if you need to actually cut something out and actually have a hole there rather than a raised edge. Circles. If you're cutting a circle, one of these picked up very, very cheap is quite good. If you've got an arched top window, if you set the cutter to the radius of the window off the actual window itself and then press it in, cut, you'll have the window match the opening in the Plasticard. Semi-abusive tools. Apparently this thing, those of you who do model engineering will recognise it. I use it to measure the width of gaps. So you'll see this later. If I want to know how big to cut a gap, I will measure the window. I'll then use it, mark up the Plasticard so I know that hole is exactly the same width as the thing I want to go in it. I don't give a monkeys what size it is, it just needs to be the same size. Tweezers for smaller parts. You add then to your variety of files, different shapes, different finesses. Add to your collection of blades, different types. Paintbrush, thick for dusting off the surface. And in the case of here, you see this surfacing is quite rough and it's got quite a few burrs on it. A wire brush, brass brush, is very good just for removing the dross off the surface there. If you're working 7mm, 4mm, there are scale-specific rulers available, so you don't have to convert millimetres or inches to your scale size. Obviously, a set of drills, useful as well. And then we start getting a little bit more esoteric in that recently bought one of these, known as a 321 block. Nice block, cheap off eBay. Best thing about it is it's square, it's flat, and it's heavy. If you're trying to put a vertical edge onto a piece of Plasticard, put that down, put the edge up to it, glue along, leave it for a bit, take it away. If you're doing a corner, same thing, one edge, second edge, you know it's 90 degrees both directions. Also handy because it's heavy, weighs things down. Different type of square. This one is very good for standing up on end, whereas these do tend to wobble and fall over. Clamps. What was that, sorry? The squares, yes. So this one, it's got a base on it. So it's very good for just standing on end and staying put, whereas the conventional square will fall over. Okay. Right, so we've talked about tools. We should also talk about solvents and other adhesives. So the go-to here for gluing together Plasticard is MEK, widely available from a huge number of suppliers. Also available off the interweb in litre bottles, so you can decant into your smaller ones. This little thing I've got here, I get asked a lot about it. It is there to stop the glue being knocked over because it does make quite a mess. This is just the inner of a roll of tape. Old children's bath toy put in there, and the best thing about that is it expands to suit the size of the bottle, or was squidged. I do put a little bit of Plasticard in the edge because it keeps the brush from rolling off. That is your go-to solvent for most uses. If you're using an ABS type plastic, you want something a bit stronger that's suitable for ABS. So that's one of those, butanol. And if you are laminating lots of thin layers and you want a little bit more time to glue the things together, Limonene smells of lemons, slower to evaporate, not as aggressive. However, saying that, it does destroy the lids of the caps. So whatever you do, keep it the right way up, not lying down, because you'll come back and find it has escaped and you're left with no cap. So that's your solvents there. Okay, just covered everything. Right. So I suppose we better start using some Plasticard now then. So you get a lot of questions about how do you actually cut and join Plasticard. Basic tools, knife, preferably sharp, ruler. And if I'm marking up and measuring, something I always do is try and maximise the distance over which your two marks are on the sheet. So if I want a bit that's only that long, I will still mark from there to there, because it takes out the error in the dimensions. So top end, I'll put the blade against the side of the sheet, put the ruler against the blade, and then mark on whatever that is. I think it was 30. Same down this end, do 30. And then hopefully, if I can find both without my glasses, it's a case of something you can do is when you draw the knife down to start with, just feel for the little nick you've made in both ends. So that means you know you're on the line. Draw backwards. You don't try and cut through in one swoop. Multiple cuts is by far the better. And you'll notice that I haven't cut all the way through. I don't want to, I don't have to. I mentioned earlier, when you do cut, you get a burr either side of the line. I want to get rid of that because it can get in the way sometimes and knock things out of square. Abuse of tools, yet again, edge of the ruler that you've just used, rub it over the back of there. That's got rid of the burr. Next stage, bend one direction, bend the other direction, snap, as easy as that. So if we want to join a piece together, I'll just cut a piece off, same methodology but using a square, quickly. So that's my other bit of plastic now. We'll take our glue. And it's as simple as dip the glue in there, you don't want a huge amount, run it down the edge, pressure, down the other side, and that is your plastic glued together. And effectively, everything I make is some very basic skills, which is cutting to the right size, gluing using a solvent, using either proprietary sheets, which are available in certain textures and finishes, or making my own textures and finishes up from other forms there. So that is basically your 101 on plastic use. We'll now look at thinking about a building. How do you choose? How do you go from this, I know what I want to do, to actually making something? So first off, my advice would be to, if it is a real building, try and find as many pictures as you possibly can of that building. Here are a few of the signal box. That's a nice close-up shot. That's a semi-distant shot, and that's one of the rear. What I will then do is I will draw lots of lines on there, work out where the vanishing point for perspective is, and try and work out how big things are from things that you probably know the size of. So doors are a good one. Generally around about 6'6" by 2'6". Can be bigger if they're external doors, 7 foot by 3 foot. Bricks are a very good one. Generally 9 inches by 3 inches, 4 layers to a foot. Gives you a good idea. Just to be careful, sometimes the older bricks can be quite a lot bigger. So we can get a lot of ideas what we want to build from this. We take note of the finishes, we take note of the windows, how things are fitted together, what overlaps with what. And next stage is to do a bit of a sketch and think about how the structure is going to fit together. So for instance, if I get a piece of paper, which I don't have, I will think about the finishing. So if we've got our stone finish going around the outside, if that's Will's stone that I'm using, that is circa 3 millimeters thick. I think about how I'm going to lap it. If the building is viewed from that side, I will do it so the front sheet of stone comes in front of the side sheets. We then look at, so that's the finishings layer. We then look at the structure behind it. So again, that will be a plastic sheet or sheets behind it. I'm thinking now about, okay, it'll come in a bit. That is generally 1 millimeters because I use 40 thou. So overall there, we've got 4 millimeters thickness. So I now know, for instance, if that is 100, I want my finished building size. This piece here will be 100 long. The next piece in, because we take allowance of the thickness of the plasticard on the outside, will be 2 lots of 3 millimeters less. So 94 if I can draw this upside down, and you work your way around for the rest of the building like that. but very much thinking how the layers going to fit together and working to your finished dimension from that perspective. What I will then generally do is, next stage is I will knock up a quick serial packet, cardboard, 3D lump, and I will put it on the layout and see how it looks. Is it the right building for the space? Is it the right size? And also, one of the things that's very difficult to get right are roofs and roof angles, particularly if it's a hipped type roof, because you can't see how tall it is from the end. So I'll put that on the layout, have a look at it, and compare it to the photographs I've got. Does it look the same? And make any adjustments at this stage. You'll also note I've put key dimensions on this, so that when I'm marking up the next stage, key things are on there that I've worked out. And it notes to self that certain things should be recessed and certain things should be proud, etc. We then start building up the building itself, and I'll discuss some of the techniques in a bit. But you can see here that I've made a basic plastic inner shell to start with, and then I've clad on the outside with the finishings. That's the route I always take, is build the structure first, the physical structure that's going to retain everything and make the structure strong and resilient and not warping. Build that first, then fit the extra layers on top. So we're talking about now building up your structure, and a lot of people I talk to when we are talking about how you're building it up, they will say Plasticard warps. And my first question to them is, so how are you building your walls up? And the answer generally comes back, I've got a layer, I'm putting another layer on top of it, another layer on top of that, another layer on top of that, and I'm gluing each layer normally over a period of time. I've glued 3 layers of 40 thou together here this morning, and I will guarantee when I come back tomorrow morning this will have developed a curve in one direction or the other. I've never quite worked out which way the curve forms, but yeah, it will. In fact, it's starting to S already. So yeah, like that, it will warp, and I don't use that method. The other problem with it is it's still quite flexible as a structure and twistable. So the next thing you can do is your structure. Think about how, say for instance, the roof beams, the big steel RSJs in this building are formed. You've got a bottom, you've got a top, and you've got a spacer between them. And that is a really strong structure, structural form, and it's one I would recommend sort of emulating on our plastic structures. So here all I've done is I've got the face of the building, and on the back of it I've stuck some strips of 40 thou, 2 strips on top of each other, and then I've stuck a separate 40 thou inner face on that. And interestingly, what you'll note is the bit I have done where it's faced front and back is straight. The bit that I haven't put the face on, so you can see what the structure is actually started to curve already, and that was only done 2 hours ago. That is significantly stronger, and hopefully the glue has dried. Yeah. One of the reasons it doesn't warp is that there are large air gaps between the 2 sheets. Any solvent that's in there has a really good chance to get out and escape. Other advantage is it's easy to cut a hole in the outer face, so you do need to perhaps plan where you're putting the ridges for fitting windows. For much larger buildings, something that needs a good deal of strength, I have developed another way of building up the wall, and that emulates how wings are made on aeroplanes. So I call it my aeroplane wing method. Outer face, strips of Plasticard on edge. Start off with the bottom, then you cut spacers, glue those on edge against the bottom one, then glue your next strip on edge and carry on building it up like that, so it looks like a ginormous bookcase. You can either leave it like that, or you can face it on the inside as well if the inside will be seen. But this is by far the strongest wall building methodology that I use. It carries a significant amount of weight, it takes a lot of abuse later on. So those are your methods for building up walls, and I'll show you here one that has been made earlier. So this is a cottage that's going right at the front of my layout. The windows are inset a bit, so I need a bit of depth on the walls. But also I'm planning on having some of the windows and doors open to see the inside as well. So I'm very keen that we have an interior on this model. This particular one measured up and made the outer side, the outer faces, allowing for the future finishes reduction. Cut the doors and windows out, shapes there, fitting them together, braced it all up, and I've also, because I want to see the inside to a certain degree, I've clad the inside as well. So that's that, but one benefit of it is it's quite hard and will take drilling, sanding, whatever you want to do to create the finishes and adjust the finishes. Not so important if it's a home layout and it's only just you with it, but if it's an exhibition layout, speaking from experience, buildings do get a lot of grief. They get things put on them, they get dropped, they fall off layouts if they're not attached, and they do get damaged. And if you look around any exhibition at the buildings, you will find splits down the sides, roofs lifting away, things curving away. This may seem over the top, but it served me well over the past 30 odd years as a method of building robust structures that stand the test of time. So that's the main structure elements for the walls. I get asked a lot about roofs as well, and I think the gut instinct when you're making a roof is just to get your two gable ends and get a sheet of Plasticard, stick it over the top, stick it over the top. Yes, you get your finished result very, very quickly. Downside to it is quite flexible, and what you'll find over time is it will lift, it will break, it will come adrift, and it is very prone to damage. The other thing is if you have glued it down on there, you can't get to the inside of your building. You might say, why do I want to get to the inside of my building? Well, Sod's Law comes in here because I have found if ever a space is inaccessible and that space has a window, somebody will put their finger through the window, push it into the inside, and you're there thinking, how on earth am I going to fit a new window in that space? So I generally make buildings so that roofs, if need be, are removable, so I can get into a later stage. So the approach I take, I'll show you the finished one first because it's probably easier to see how it works. We've got the gable ends there, and that's the finished level I work to there, and the front and back edges. All these other supports around here don't actually support the roof, they are lower than the roof itself. And this roof is built up a bit like a ship hull. And fits in the building. On top of it, the very last layer of the structure of the roof overlaps the gable ends, giving you something to put your tiles on. And the front and backs overlap the front of the building, somewhere for your gutter to run into. But you can see there straight away that I can take that off to one side. I can detail up and do the tiling completely separately, which is much easier like that than it is on the building. Building chimneys to it, paint up, because roofs generally aren't the same colour as walls. It's just handy to work on it. So how do I make those? As I said earlier, it's a bit like a upside down boat. So a layer of 40 thou for the base, just has to fit inside the building. Some 40,000 as well to take the shape of the ridge line, Well, I say take the shape of the ridgeline because with this method you can easily model a bow in the roof. Just cut a curve in the top of the ridge. I then just cut a whole series of triangles that fit between the edge and the ridgeline and fit those in on both sides. But before I go any further, key point here, you'll notice there's holes in this roof. We will be creating, when we stick the roof on, an enclosed space. Mentioned earlier, solvent in an enclosed space will slowly over time lead to warping and problems with your plastic. So drill a hole in the bottom, just needs to be one per cell area. Job's done, doesn't have to be neat, doesn't have to be tidy. So my next method, this method I use now, again it may seem long-winded compared to just shoving a sheet of plasticard over the top of it. But the reason I do it is a couple of fold. I've deliberately here cut a roof that isn't square. It's got a peculiar shape to it, and the ridge line also isn't flat. So both of these roofs, the actual plan of them, isn't a nice rectangle. And also when you look down it, the actual roof, because it changes angle and height, is twisted. If you try and get a sheet of plasticard to take up that shape on its own, it will fight you back, and it will keep fighting you back, and you'll keep gluing it down and it'll keep popping because you won't be able to get the glue in particularly easily there. You're also trying to stretch the plasticard into a shape it doesn't want to take, which then sets up stresses in your roof, so it will naturally over time want to try and straighten out somehow. So you might find the plasticard itself, the sheet, straightens out and the rest of your roof pops up. With this method, which is basically using thin strips of 20,000 plasticard, so 0.5 millimetre, I cut same thickness strips, and I apply the bottom one first to give me the overlap I want over the structure of the building. Put that one in first, and because it is just a narrow strip, the benefit here is you get your glue brush, you can start off gluing down the bottom, you can glue down the edge, but you can also get your paintbrush in and glue up the back inside. Press down, that is not coming adrift then. Next layer, 20 thou, push it up to it, glue along the joint, give it a good squidge down. Again, paintbrush behind, push, 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 that is stuck. If your roof is a very unusual shape, very curved, very distorted, you may find that you'll get a gap between parallel sections of plasticard. It doesn't matter. But what I also do is I make sure that I can actually get, for the very last big strip, I can get the paintbrush in. The final strip, put it on right at the top, and it can go across and beyond the ridge line. Leave it there, that's fine. So you can see in this case, it overlaps the ridge line, no problem. Once you've done that, I then take some more 20 thou. These strips can be wider, depending how straight or flat your roof is. But I put them at 90 degrees. And this top layer is lapped so that it goes over the top of the wall. So if our gable end finishes there is however much your building needs, if it's 6 inches, 3 inches, a foot, however much it's overlapped. And this will give you something to glue your tiles onto and get a nice fine finish on the roof edge. So strips, 90 degrees that way, all butted up. It's really good for using up little bits of plasticard because you can just stick them on, cut them off, trim them, just keep going. And after you've done layers both different directions, you then just cut back to the ridge line there. I've just shown a few tiles on there. These are the York model making self-adhesive ones, but we can use whatever you fancy, card, whatever. But that's generally how I make a roof. Most of my roofs on 2-storey buildings are removable. and again, nice and robust, won't go anywhere. Right, so what we're doing for time, got a few minutes. I think now what we'll do is perhaps, if I find the parts I was looking for, a few more examples of things we've made here. So this is a bridge abutment using the Wills coarse stone. Very suitable in my view for 7mm as well as 4mm. You'll see from behind there is basically a fascia layer of white Plasticard. It's got the bookcase strengthening behind it. Once that's all in place, and I've also put some nice 45-degree bracings in the corner there for the deck when it goes on, etc. Once that's done, I will then start detailing the outside. I've used Wills here. How to use Wills. Again, this is something I get a lot of questions on. It is thick, as we mentioned, and I get people telling me to use hand saws, hacksaws, you name it, to cut this stuff. This is where the Tamiya scriber comes in very useful, because it's good just to keep cutting through a few times. I can already feel it's getting stuck in the texture on the other side, and hopefully that will either snap, yes, and then you get your sharp blade in, separate it. This is quick and easy as that. So you don't need to persist with your hacksaws and other things. That's all right. When we come into the 90-degree corners, if you then butt that up, what you'll notice is you've got a horrible plain edge. So what I tend to do here is I will put, let's see what we've got. I will put the first layer on, and I will slightly take it past the edge of the structure, glue that on, and then file it back flush. Once that bit is on, I will then take the second piece, put it on, butt it up against there, again slightly proud, and then once the glue is set, file it back flush. That will give you a nice corner with no gaps. We then go in either with a variety of tools, scribes, saws, blades, these sort of things, and reintroduce the coursing around the corner. What you will find, depending on where you've cut the sheet, you may end up, I'm just looking for one, yes, you may end up with a very, very narrow, thin layer of stone there. In that case, what I'll do, I will take some filler. This is just car body filler, and I will blob in the areas that I'm not happy with, that look like they're sufficiently big. Just blob it on there, leave it to dry, come back later, sort of sand it back, and then go in with the variety of tools to reintroduce the various blocks into size. And you can see that has been done on that side there. So we've got some much bigger stones, some smaller stones, just to add a little bit of variety and make it look more like it's a corner rather than two joints just butted together. Next question I get asked a lot is windows. So my methodology is generally I will mark up the outer skin. Well, I mark up the inner structure roughly where I need the windows to make sure I haven't got ribs and things in the way. But then when I'm doing the outside, I will mark up the actual size of the opening I want in that finish. I will cut out the hole from that finishing layer whilst it's off the model, because it's much easier to do. I will then glue it onto the model and go round with my scalpel around the outside, diagonals across the middle, a couple of cuts, and then it should just push out from the middle and pop out like that. It will leave a slight burr and a slight raise there, so the next step is you go in and you start cleaning it off with files, but you just have to clean up the white Plasticard, not the front structure. We then start looking at the edge detail for the brickwork or stonework, and again you're just trying to look to take the coursing round the corner, so knife in along the course, take it round the corner, give it a bit of a push, and then go over afterwards, making it slightly wider so it matches the depth and the brick coursing there. So that's those. The next one I was going to do, if I can find the bits that I pre-cut. Okay, I can't find them, but there we go. So we've then got one of the finishes I use quite a lot of is Slater's corrugated sheet. There is a good side to the corrugations and a bad side. One looks quite flat, so you make sure you've got it the right way around. But I don't know if you can see on the cameras, there are little bolt heads in there. I will draw those up on the rear first, the positions, and then go over with my scribe to push those in. I will then also cut the Slater's corrugated sheet into the sizes I want, and that's the visual end size of the sheet, not allowing for any overlaps whatsoever. I don't overlap these sheets, because even in 7mm, I think it still looks too coarse. It just doesn't sit right. I will then, so I've separated these out into individual sheets of corrugation, stick them down as a first layer. I will then stick down a layer of 10,000 behind it, just a very narrow strip. And the next layer that comes along, I will put the leading edge over the top of that, just so you get a very, very slight raise and a lip to the following layer. And that looks a lot more realistic than trying to overlap actual sheets, which just generally looks too coarse to my eyes, at least. Yes, so that is most of what I wanted to cover. I think the other elements to cover now are, I don't just use Plasticard in the builds. I'm a firm believer in the best material for the job. So for the likes of this building here, the chimney pots are 3D printed. The batten holders for the drain pipe are 3D printed. Again, this wall here, this is a 4mm example. This has been 3D printed for me on a printer, and some of these capping stones as well. I'll also use etched windows, doors, railings to suit, resin where it's applicable. So just look at what is available and don't rule it out just because it's a different material. Okay, I think that is, given the time, all I want to cover at this point. So have we got any questions? Was it, sorry? Yes, you can have a look. I'll be here after the filming stops and we can just have a poke. I'll also be downstairs on stand D6 when I pack this lot up and take it back again. So with a lot more tools and bits and bobs to show.
When you're doing stonework, you get the outer corners. Do you find you need any filler?
Yes, definitely. So in the example here, I used to, when I was first starting out, try to chamfer these at 45 degrees and get it in. It doesn't work. You always get in with gaps, and you also end up with the small, narrow stones as well, which look wrong. So you end up using filler anyway, so just go with it and butt them up, file them down, put the filler on, form the stones from scratch again. Just it's Halford's knifing putty. Some people use Squadron, some people use Tamiya. There's a variety of different sorts out there. Any more?
Show us again
How we did the window? Yeah, no problem. So the first bit is you're planning where the windows are going to be in your structure, in your sketch. You allow for those positions in the structure carcass you make, so you know there's going to be a window there. Don't put anything in the way like a beam or a support. So that'll be the case right there. I then will mark up the window size on the outer finishing layer first. So if this Plasticard sheet, the brick Plasticard was completely separate, I would mark it up on there. Then stick the finishings on the outer carcass. And having previously removed the this bit whilst the brick was off the model, then just cut round the outside, down the middle, diagonally a few times. And having done that, it should push out from the middle. Once it's pushed out from the middle, file around the outside to make it nice and square, but not the outer surface, just the inner surface. And then use your knife to reintroduce the coursing round the corner, like that. Same for doors. Lintels can be put on afterwards. If there's a brick arch over the top, when I'm planning the sheet, I will cut the arc out before I fix it to here, so you've got the rebate for the arched the bricks to go in afterwards. Okay. If it's a thin sheet like the Slaters, you don't need it bonded everywhere. You only really need it bonded around the actual outside and round openings as an absolute minimum. Anything else is a bonus. If it's a really large sheet, I would use the where's it gone? The Limonene, because you can brush it on, apply the plastic, brush a bit more on, apply the plastic, brush a bit more on, apply the plastic, and that will go in there. But it won't grab immediately, it won't take immediately, so you've got to put it to one side under a weight to keep it going. If I am using this evil stuff, first of all, file the back off because there are raised pips. Then use the Tamiya scriber. Put lines, deep lines in the finish, so that when you glue this stuff onto your plastic carcass, you can run glue down the top joint there, and it will run all the way down these little grooves and just help tack a little area along there as well. Okay, I think we're up for time, are we?
Yeah, no, you're fine for time.
Okay.
Yeah.
Thank you. Thank you all.